Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat, guys. If my voice is clearly audible to everyone and everything is working fine, then I will share my screen and we'll discuss the problem of the day for yesterday. That was K largest element. Hi Rishit. All of you can give me a +1, guys, and hit the like button if everything is working fine, and then definitely I'll proceed further as well. Okay, so now let me share my screen as well so that we can proceed further with this one. All right. So yeah, things are getting shared very good. So okay. So let me now start with the discussion. So just let's quickly open the GFG POD so that we can have a look at it. Okay. So the problem of the day that we are going to discuss is K largest elements. Okay, so let us quickly discuss this problem right now. K largest elements. Okay, so there is one thing, since we are discussing this, so I want to tell you about one thing, right? If you are asked K smallest, right, if something is written in terms of K smallest, K largest, okay, or you can say K closest, right? If things like that, if things like this is written, so there is one particular data structure that we need to use, right? So normally it is known as the heap data structure, right? So either you will use the min heap, right? Either you will use the min heap or you will use the max heap. Okay, that is for sure. I will tell you in which cases what will be used. But whenever K smallest, K largest, K closest, or anything like that, this is written, okay, then in that case, you need to do what? You need to use the heap data structure, that is either the min heap, max heap, that is nothing but also known as priority queue. Is this part clear to everyone? Please write yes in the chat and then I will proceed further. Okay, so whenever there is a problem, if you are new to DSA, then whenever there is a problem in which you are asked about the K smallest, K largest, K closest, then you need to consider the priority queue data structure, or you can say the heap data structure, right? Because heap is implemented in terms of priority queue. So heap you have the min heap and the max heap, right? Okay, very good. Now moving on to this particular problem, what does this problem say here? So this problem says that we'll be given an array, okay, and when this array will be given to us, so we have to find we have to do what? We have to print the K largest elements. Okay, so what is the method one? Okay, we will be given an array and we have to print the K largest elements, right? We have to print the K largest element. So if you have to print the K largest element, guys, so what can be the method one, right? One of the very basic method that we can use is that we can basically sort the array. Okay, and sorting the array will take order of n log n time, right? And when you sort the array, after that what will happen is you can print the let's say you will sort the array in the ascending order, then starting from K minus 1 till the then what you can do is you can print the elements, right? Or you can sort the array in descending order, right? Descending order you can sort, and you can print the last K elements. Is that clear? Please write yes in the chat. So that will take n log n time. Is that clear? Please write yes in the chat. Method one can be that I can use sorting, and when I will use the sorting approach, so I can sort the array in the decreasing order and from the largest to the smallest, and then what will happen? I will take n log n time for sorting, and in that case we can print the last K elements. Is that clear to everyone? Right. So like we will have a descending order array and then we can print. Okay, so this point is clear to everyone. If this much point is clear, so make sure to hit the like button as well, guys, because the number of people watching are more compared to the number of likes. Okay, now what can be the now what is the issue with this? So we have the time complexity of this approach as n log of log n. Okay, but we can try to reduce it also, because what we can try to do is, if we will use the heap data structure, then we can make it n like we can make it what we can make it something like we can improve it. Okay, so we can make it n log k. How we can make it, I will tell you. So we can reduce the complexity, because remember this thing, that k is always going to be less than equal to n. Okay, so k is always going to be either less than n or it will be equal to n. So that is why k will be smaller most of the times compared to n for many of majority of the test cases. So that is why we will try to have the complexity in terms of k as well. Okay, so what will do is, if also one more thing you need to notice, whenever somebody will ask me to find the K largest element, okay, you can use a lot of things, but the general approach that I use is that whenever somebody will ask you to use the K largest, no, then in that case whenever somebody will ask you to find the largest, okay, so in that case what you should use is you should use the min heap. Okay, is that clear? You should use the min heap min heap, right? So min heap priority queue you should declare. Okay, if somebody is asking me to find the k smallest, okay, let's say k smallest, or I have to find k closest, right, something of this kind, then in that case I should use the max heap. Okay, max heap. Is this much part clear till now? When I will do the question, then more things will be clear. But at least till now, you are clear that whenever I have to find the largest or highest or something like that, and k largest, k highest or something like that, then I will use the min heap. Okay. So when I am so I have to think about the opposite heap. Okay. In that case, please write OPP in the chat. Okay. I have to use the opposite heap when I have to find the largest. Okay, then I will use the min heap. Okay, and when I have to find the smallest or the closest, right, then I have to use the max heap. Is that clear? So I have to think in terms of the opposite direction. Okay, you can take a screenshot of this page also if you want. Okay, please write OPP or +1 in the chat and hit the like button as well, guys. If till now everyone is clear, just let me know if you are clear with this or not, guys. Okay, you can hit the like button as well if everyone is clear till now. Please give me a +1 in the chat if this part is clear. I will explain a bit more why this happens. So basically, when you are talking about the largest, then you will use the min heap. Why? Can you explain what is max heap and min heap? So basically, na, in the min heap, the minimum, like, see, in the min heap, what will happen in the min heap? Okay, if you talk about the min heap, so min heap, in the min heap, what happens? Minimum element is at the top. Okay, minimum element is at the top. Okay, is at the top, is at the top. And in the max heap, what happens is in the max heap, right, maximum element is at the top. Okay, amongst whatever elements are there, so in that maximum element will be at the top. Maximum element will be at the top. Okay, will be at the top. Okay, is this much part clear to everyone? Then I will proceed further. Okay, so whenever I have to find the largest, then I have to use the min heap. Okay, whenever I have to find the closest or smallest, things like that, whenever I have to find lesser, then I will use the max heap. Now why is that so? I will explain this also, right? So what will happen here is also one more thing. So let's say there are how many elements? Uh, let's say there are m number of elements. Okay, let's say there are m elements in a heap. Okay, and if there are m elements in the heap, right, if there are m elements in the heap, right, suppose there are m elements in the heap present there. Okay, if there are m elements present in the heap, then in order to get the maximum element or the minimum element, okay, in order to get the maximum element or the minimum element, right, depending on the max heap, right, or the min heap, right, whichever heap it is, min heap, in order, like, if there are m elements, so there will be some time taken for getting the maximum element at the top. So if there are m elements in the heap, then the algorithm takes order of log k time. There is the heap pipe log m time. Okay, if there are m elements inside the heap, so for getting the maximum element at the top, it takes log m time, and this is known as the heapify process. HEAPIFY heapify process. Is this also clear to everyone? Please write yes in the chat. Okay, so basically what happens is there is a heapify process. If there are m number of elements at a particular point of time, right, or let's say there are z number of elements at a particular point of time, then it will take log z time to keep the maximum element at the top or minimum element at the top, depending whether it is max heap or min heap respectively. Is that clear? Please write yes in the chat. So heapify process, that is getting maximum element at the top or minimum element at the top depending on the type of heap, how much time it takes order of log m time. So basically the whatever number of elements are present. Is this also clear? Okay, very good, guys. Now after this, moving on, you will observe one thing, right? Let's take this example. So let's say that if we have this particular example, so we have been given the k value as 2. Okay, and the number of elements that we have been given is 5, so we will not consider that. And now what we will have is we'll have the array. So we have 12, suppose we have 5, we have 787. Okay, then after that we have 1, and then we have what, we have 23 as well. Okay, guys, now what we will do is we will declare, if we are finding the k largest, so which kind of heap we will develop? See, we need to find the k largest elements. Okay, remember that we need to find the k largest element. So if you want to find the k largest, so we will declare a max heap. Okay, we will declare a max heap. Okay, if you have to find the k largest, guys, so you will do what? You will declare the max heap. Okay, k largest. If you have to find the k largest, then you're going to declare a max heap, right? Sorry, min heap, very sorry, min heap, because opposite thing you will declare, sorry. So you'll declare the min heap here, sorry guys, you will declare the min heap, very sorry. Yeah, min heap, correct, correct, sorry Rishit. Yeah, so normally what you can do is you can declare the min heap, the opposite. If it is asking for the largest, then you should declare the min heap, right? So in this, what will happen, minimum element will be at the top, right? Minimum will come at the top, right? Will come at the top, right? This is what is going to happen here. Now after this particular point of time, what will happen is I will iterate through the elements one by one, and I will not allow the size of my heap to be greater than k. Please write k in the chat, okay? I will not allow my size of the heap to be more than k, right? Whenever the size of the heap of the min heap will become more than k, then I will remove the elements from it, okay? So I will I will not allow the size of the heap to be more than k. Is that clear? So like in this case, I will not allow the number of elements inside the heap to be more than 2. Okay, so what I will do is I will insert the very first element. So I'll insert this 12. Okay, so I'll insert 12 inside the heap. Now I will check. So what is the size? Can I say that the size of the heap is less than equal to k? Yes, the size of the heap is less than equal to 2, because there is only one element. After that, I'll move to the next element. So after that, I'll move to this element 5. So I'll insert it. Now the size is the number of elements in the heap is 2, and 2 is less equal to k, because two elements are there and k value is also 2. After that, I will insert the next element. So when I'll insert the next element, I think next element is what, 787 itself, yeah. So then I will insert the next element. So 787 is the next element. Okay, so when I will insert it, so now the size becomes 3, right? Can I say this? Yes, the size of the heap becomes, size of heap becomes what, 3, which is greater than k. Okay, which is greater than 2, you can say 3 is greater than 2 here. So then I have to pop out, I have to remove the element. Okay, so which element should I remove? So since this is a min heap now, so you can understand, I want the larger elements to be there, I want the larger elements to be there. So in this case, whichever is the element at the top, that will be removed. So in this case, you can see that 5 will be at the top, right? Why 5 will be at the top? Because 5 is the minimum element. Since this is a min heap, so whatever is the minimum element, that will be at the top, and whenever I will remove, so the topmost element will be removed. So smallest element will be at the top, because this is a min heap. And if I remove the smallest element, then I don't have any issue. Please write +1 in the chat, guys, and hit the like button as well if you are getting this right. Since I want the k largest elements, so if the size of the heap becomes more than k, right, so then which kind of elements I should remove? I should remove the smaller elements. That is why I have declared a min heap. Is this part clear to everyone? Please tell me in the chat, guys. Please write clear in the chat and hit the like button as well if you are clear with this idea. Is this idea pretty much clear to everybody? Yes or no? Right, guys? Okay, you said min heap. Yeah, I Jagatishan, I have declared a min heap only right now. So since I have a min heap, no, right? So since I have declared a min heap, so minimum element will be at the top. So when I will be removing, so so topmost element will be removed. So topmost element is 5, so it will get removed. Is that clear? And it will not have any effect. Please write +1 if you are understanding this. So that is why we have declared the opposite. Like when we want to find the largest, so we have declared a min heap, so that whenever we are removing, so the minimum elements are getting removed and larger elements are still there inside the heap. Okay, so 5 gets removed. Okay, so 5 gets removed out of the heap. Now after that, size is 2, so that is fine. After that, we move to the next element, so we move to 1. Then we insert 1 inside the heap as well. Now the size of the heap becomes what? Size becomes 3. So 3 is greater than k. So when the size becomes greater than k, in that case, what will I do, guys? When the size of the heap becomes greater than k, right? So in that case, I have to remove the element, because I don't want more than k elements at a time, right? Because if I have k elements, right, so in that case, the heapify process for getting the topmost element will take log k time. Okay, if I have k elements at a particular point of time, so the heapify process will take log of k time. Okay, because if k is the maximum size. So now what will happen? I have this element 1 here. Okay, so now what will be the topmost element? Topmost element will be 1. Since the size is greater than is greater than k. Okay, so since the size is greater than 2, then I will remove the topmost element again. Please write +1 in the chat, guys, and hit the like button. So I will remove this particular guy. Is that clear to everyone? Please write yes or no in the chat, guys, and if you're clear, please hit the like button. So again, I remove the topmost element. So since this is a min heap, so minimum, so at the top, which element will be there? Minimum element will be there, right? And if I'm removing a lower element, minimum element, so it will not impact my final answer, because larger elements will still be there. Okay, So I will remove this guy. So when I remove this guy, after that what will happen is I'll move to the next guy. So I'll move to this 22. Now I'll insert 20, 23. So I will insert 23 inside the heap. Now again, what happens? The size of the heap is 3. Okay, which becomes greater than k, which becomes greater than k. So again, I have to say that I will remove what? I will remove the minimum element here, right? Because I will remove the top. Okay, so I'll remove the heap topmost element of the heap. So now what is going to be at the top? 12 is going to be at the top because the minimum element, since this is a min heap, so heapify process will take log k time and the minimum element will come at the top. Okay, so 12 will be removed from here. Okay, and after this you will observe that after this happens, then when we reach the end of the array, so only two elements are remaining in the array, and you can clearly observe that these two elements are what? These two elements are the k largest elements. Okay, what are the two largest elements of this array? The answer is 23 and 787. So you can see that the answer is 23 and 787. Is this much part clear to everyone? Will min heap sort? No, no. Inside, it does not, like, actually only it keeps the minimum at the top. Okay, rest of the elements are not sorted. Rest of the things are not in ascending order. Actually, the implementation of the min heap is in terms of, I think, BST. Okay, if I'm not wrong, it is in terms of BST. So basically, we try to keep the topmost node as the minimum element if we have declared this thing. So there is an internal implementation for that, but the rest of the things will not be in ascending order. That is not going to be true. Okay, it is not true. Actually, inside internally, it is implemented in form of a tree. So it is not true, right? It only gives us the kth largest element, like minimum element or the maximum element, whatever you have, whatever kind of heap you have declared in log of k time. So the heapify process takes log k time only, because when you declare the tree, then the complexity becomes log of k, because the maximum level is log of k, right? So that is why. Is that clear till now, guys? Please let me know. Is it clear till now? Then yeah, only minimum element will be at the top if we have declared a mini, and rest nothing will be sorted inside, you can say, right? For the rest of the elements you cannot say anything, right? So yeah, now this is the case. Now after this, when you have ended the iteration, then after this you will take out the elements one by one. So whatever elements are left, they are your k largest elements. So is that clear? Like, is this part clear also to everyone, why we need to declare the opposite, right? Because when you want the k largest now, so you want to remove the irrelevant smaller elements. Okay, so that is why why we declare a mini, because we want to remove the smaller elements. That is why. Is that clear? Please write +1, agree, and hit the like button as well if this concept is clear now and you're watching this video. So please hit the like button. This is very, very important. You will see this question, kth smallest element of a matrix, and there are a lot of questions that are there based on this, right, that are asked in Google and a lot of companies. So if you're clear with this logic, then in future you will be able to relate to the things very easily, right? So that is why when we have to find k smallest, right, or kth is smallest, something like that, then we use the max heap, because why we use the max heap? Because then we remove the maximum elements, right? So from the top we remove the maximum elements, because the greater elements are irrelevant for us in that case, right? So now what will happen is we will take out this element. Okay, so which element will be taken out first? 23 will be taken out first. Please write 23 in the chat, guys, right? Which element will be taken out at the very first? 23 will be taken out. Okay, because 23 is the minimum out of this, right? Then after that, after 23 is taken out, then you will get what? Then you will get 787. Okay, so after that 787 will be taken out. But in so when you will take out, so in an array, when you will store, so in this format the array elements will get stored, but actually you need to return the answer in the decreasing order. Okay, so in that case what you need to do is, whatever answer you have stored, you need to reverse this also. Okay, so we will reverse this. Please write yes in the chat, because when I will be taking out, so the minimum elements will come first. So 23 will come and then 784. So since I have to return in the opposite order, you can see that I have to return as per 787 and 23. So I have to reverse the array. So I will do 787 and then 23. Okay, is this clear to everyone? Please write yes in the chat. So what is the time complexity of the approach that we have discussed so far, right? So you can understand one thing very clearly, right? So I use the min heap here, so I will just write it. Okay, I use the min heap here, so you can understand one thing, right? That for one particular point of time, what is the maximum complexity, like what is the complexity of the heapify process that is getting the top element? It is log k, right? Please write yes in the chat. Okay, because maximum like heapify process takes log k time, because whatever is the size of the array, now it is log k. So if you will consider in the worst case, how many elements I need to consider? So you can say that in the worst case, if you say n indexes, although it will be n minus k only, I think something like that. So yeah, this will be n log k, which is lesser. So this complexity will be nothing but n log k. Okay, is this point clear to everyone? So the complexity will be, if I will keep this as n only, right? N is the number of elements in the array, so this will be n log k only, right? Maximum. So is that clear? So n log k is going to be what? And you can understand one thing, that n log k, okay, it is lesser than n log n, right? N log k is lesser than n log n. Why? Because you can understand one thing very clearly here now, because k is always going to be between n to 1, right? So k, for majority of the test cases, or for major part of the test cases, k is going to be lesser than n only, right? So that is why. So that is why this will be more optimal, right? Is that clear? Please write +1 in the chat, heap op in the chat if you are clear, right? Okay, you can write heap op in the chat, okay, if you're clear with this, and you can give me a +1. And also guys, please hit the like button if you're clear till now, then I will write the code for it as well. Okay, is it clear to everybody? You can hit the like button, guys. Can we reach 10 likes today? Okay, very good. Now I will try to write the code for all of you. Can we reach, let's say, 10 likes? You can hit the like button if you haven't already. So what I will do is, first of all, I'll declare a vector int. Okay, let's say initially answer that I'll be storing, right? And in that I'll be storing the list, and I will have a priority, right? Q underscore QUEUE. Okay, and I'll declare a min heap. With what kind of heap? I will declare a min heap. So vector int, and this is the syntax for a min heap. Okay, and then I will write greater, then I will write int, and then this thing. Okay, then yeah, I think this is getting closed now properly. Yeah, so I'll name it as PQ. Then I'll start iterating for all the elements. So what I will do is, for, okay, and then we'll say that int I will start from 0. Guys, you can hit the like button if you are clear till now. I is lesser than n, then I will do an I plus plus right here. And what we will do is, we will simply push the ith element inside. So PQ dot push ARR of I. Okay, so we'll push the ith element inside. And when will we pop out? So if it happens that PQ dot size, okay, if it becomes greater than k, then in that case what we are going to do is, we are going to do PQ dot pop. Okay, we are going to pop out the minimum element. Okay, pop out the minimum element. Can you explain in Java? Similar thing will be in Java, only the syntax will be different. Okay, almost the same thing will be there. I will just try to show you. If I have a Java code, then I will try to show you. Okay, don't worry on this part, but please focus on the logic. So suppose that I have declared a main heap, okay, in Java or any language, then I will push the ith element inside, and I will check if the heap size becomes greater than k, then I will pop this element out. And at the end, what will happen? All the elements that will be there will be the k largest elements. Okay, so what I will say is that until the priority queue has got the elements, so I need to pop them out, and I need to push them inside the array. So I will inside the list. So I will say that uh, answer dot push back pq dot top. So I'll keep on pushing back all the elements of the priority queue one by one, and I'll keep on popping them out of the priority queue. And at the very end, what I can say is that before returning, I need to reverse my answer as well. So reverse answer dot begin, comma answer dot end. Okay, because when I store, so since I've used a mini, so the elements are stored in ascending order, but I need to return the answer in decreasing order. Okay, so then I will just return this particular answer thing. Let me see if this works or not, guys. Are you all clear till now? Please hit the like button if you are clear till now, guys. Okay, it says some kind of error is there. What is the error here? Greater int greater vector int priority QUEUE Have I made any mistakes here anywhere? Uh, mm, let's just do this. Let's see. Okay, so basically I declared extra. Yeah, yeah, correct. So it is working fine on the samples. Let's try and submit this code to check if the code is getting accepted or not, guys. So you can see that it gets accepted, right? Please write ACOP in the chat and clear plus plus in the chat if everyone is clear till now. Is everyone clear till now? Please hit the like button if you're clear till now, because you can see that this problem gets accepted, right? So what you can do is, please hit the like button. Okay, if you're clear till now, so please hit the like button. Okay, give me a +1, or you can write clear in the chat and tell me if you're clear. ACOP also in the chat is fine, right? hit the like button also, guys. Okay, so till now everyone is clear. Now if you want to discuss the Java code, so if I have a Java code I can show you. I don't have it, but I think when you will look in the solution part, so you will get the Java code, so no worries for that. Okay, you can check that out, Jagdishan. But basically you have to just check out the syntax for declaring the min heap. Okay, and other than this, instead of pq.top you will use pq.peak, and here pq.pop will be the same, and reverse, in the reverse you will use collection.reverse or something like that in your language, so Java. Okay, that is the only difference that will be there. Now let me quickly copy this code and paste it in the chat as well. So is this code clear to everyone? Please write yes in the chat. Everyone is very happy with this understanding or not? I hope that all of you are pretty much clear with this idea and everything. Now I will submit this and basically compile this code. I hope that you enjoyed this particular session, guys. Okay, now let me just paste the link here, and yeah, so I've pasted the link of the code as well. And you can see this problem, that is k largest element, this is asked in Amazon. Okay, you can see here this particular problem was asked in Amazon, it was also asked in Microsoft, it was also asked in Samsung, it was also asked in Walmart and Google. So a lot of companies have basically asked this particular problem, right? So that is how you can solve this particular problem, and I hope that everyone is clear with it. Okay, very good, guys, very good that you are super clear. Is it happens daily? Yes, Ramu Badri. The live session happens daily from it starts at 12 a.m. in the night every day. Okay, so you can subscribe the channel if you haven't. So this was it for today's session, guys. I hope that you enjoyed the session for today, and I hope that you liked our session. Okay, in case if you have understood and you're watching the recording, or if you are watching the session itself, so please in the comment section make sure to comment down understood or clear in the chat. And thank you everyone, and I'll see you with another problem of the day tomorrow. Till then, good night, take care, and keep coding, guys. Thanks a lot for joining. Thank you, and please make sure to hit the like button. Thank you, guys.